Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 210. Course Schedule 2. This is a legendary graph problem that tests your ability to find a valid sequence in a world of dependencies. Let's look at the problem statement. We have a set of courses we need to take, and a list of prerequisites. For example, the pair 1, 0 means you must take course 0 before taking course 1. Our goal? Return the exact order to finish all courses. If it is impossible because of a circular dependency, return an empty array. Think of it like a master architect's blueprint. You are building a futuristic skyscraper. You cannot install the glass windows until the steel frame is up, and you cannot build the frame until the foundation is poured. Some modules are ready to build right now because they have no dependencies. As we finish one module, it unlocks the next ones. If we find a circular dependency, the whole project stalls. To solve this, we use Kahn's algorithm. First, we build an adjacency list to represent our graph, and an in-degree array to track how many dependencies each course has. Any course with an in-degree of 0 is ready to be taken. Let's dive into the dry run. Look at the screen. We have 4 courses, numbered 0 to 3. Our prerequisites are, 1 depends on 0, 2 depends on 0, and 3 depends on both 1 and 2. Look at our in-degree array at the top. Course 0 has an in-degree of 0, it is ready. Courses 1 and 2 have an in-degree of 1, and course 3 has an in-degree of 2. We start by adding course 0 to our queue. We take course 0, and add it to our result. Now, we look at the courses that depended on 0, which are 1 and 2. We decrement their in-degrees. Now, both 1 and 2 have an in-degree of 0. They are unlocked. We add 1 and 2 to our queue. Next, we take course 1. It was a prerequisite for course 3, so we decrement 3's in-degree from 2 down to 1. Next, we take course 2. It was also a prerequisite for course 3, so we decrement 3's in-degree again. Now, 3 has an in-degree of 0. It is finally unlocked. We take course 3, and add it to our result. We have finished all 4 courses. Our final order is 0, 1, 2, 3. Project complete. Now, let's look at the Python code. We start by building our adjacency list and in-degree array. We find all courses with in-degree 0 and add them to a queue. While the queue is not empty, we pop a course, add it to our order, and for each of its neighbors, we reduce their in-degree by 1. If a neighbor's in-degree hits 0, we add it to the queue. Finally, if our order contains all courses, we return it. Otherwise, we return an empty array. Looking at the complexity, the time complexity is O of V plus E, where V is the number of courses and E is the number of prerequisites. We visit every node and edge exactly once. The space complexity is also O of V plus E, to store our graph and in-degree array. And that is Course Schedule 2 mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.